Are you fascinated by the power of large language models in natural language processing? While these models have achieved remarkable performance, they are not without challenges. Two such issues are catastrophic forgetting and hallucination. This video will provide a simple and technical introduction to these concepts, explain their impact on language models, and discuss techniques used to mitigate them. We'll explore these topics through the lens of translation and text generation examples, making them accessible for you with a basic understanding of machine learning concepts. So let's get started with understanding what is catastrophic forgetting. Basically, catastrophic forgetting in large language models refers to the issue where the model trained on a large dataset gradually loses its ability to perform well on previous learned tasks as it learns new tasks. And this happens because the model's neural network has a limited capacity to retain information from its training data. To understand this better, consider the language model initially trained to translate simple English sentences into Spanish. As the model is further trained on new tasks such as translating complex sentence or recognizing sentiment in text, it may start to perform poorly on the original translation task. To address catastrophic forgetting, continual learning techniques can be used which help the model learn new tasks while maintaining its performance on old tasks. Approaches like selective updating and episodic memory are examples of techniques used to mitigate catastrophic forgetting. Now, what is selective updating? Basically, selective updating involves selectively updating only the parts of models that are relevant to the new task while retaining the knowledge from previous tasks. And this helps maintain the model's performance on old tasks while improving its performance on new tasks. Then comes episodic memory. Now, episodic memory involves storing information about the previous task in a separate memory structure within the model. And this allows the model to access this information when needed even as it learns new tasks. Episodic memory can be implemented using techniques like neural networks with long short-term memory or gated recurrent units. So to summarize this, we can say catastrophic forgetting is a common issue in large language models, but it can be addressed by employing appropriate techniques that allow the model to learn new tasks without forgetting previously learned information. By doing so, the model's performance can be improved across a wide range of tasks. Next comes hallucination. Now, this hallucination in large language models refers to the generation of nonsensical, irrelevant, or incorrect information by the model. And this happens when the model generates text that does not have any basis in the input or context, often due to its large parameter space and the complex interaction within the model. For example, consider the language model that is asked to complete a sentence. If the model has learned to generate text by predicting the most likely next word based on the input, it may generate a coherent text that makes no sense. And this happens when the model has learned patterns in its training data but has not learned the context and relevance of this generated information. To mitigate hallucinations, researchers are developing techniques that encourage the model to generate text that is coherent, relevant, and consistent with the input and context. Approaches like incorporating external knowledge sources, incorporating more context-aware mechanisms, and using techniques like adversarial training can reduce hallucination. So to summarize this, we can say hallucination is a common issue in large language models where the model generates nonsensical or incorrect information. By employing techniques that encourage coherent and relevant text generation, it is possible to reduce the occurrence of hallucination in language models. And this leads to improved model performance and more trustworthy interaction between the model and users. Thank you.